Problem 88, merge sorted arrays. In this problem, we are given two numeric arrays, num1 and num2. Both are pre-sorted in an ascending order, and the goal is to merge these two arrays together into a single array while maintaining the non-descending sort order. A slight twist in the problem is that we should not return anything from this function that we're going to be writing. Instead, we have to modify the first array in place. So modify nums1 in place instead. For that reason, the nums1 array has empty slots available at the end, the exactly correct number of empty slots to accommodate all of the elements from the second array. Let's talk about a couple of approaches that we should not take. So solutions that might pass LeetCode's testing system, but would still not be considered good solution. If we merge these two arrays somehow without maintaining the sort order, so in fact not even using the fact that these two arrays are pre-sorted for us, and then we sort the merged array. This is a solution that is technically feasible, but it would be too slow and it would just not use important facts that both of these integers are pre-sorted in a non-descending order. In fact, maybe we should actually try that solution and see whether LeetCode allows us to pass, whether the tests are rigorous enough in terms of timing and memory usage, etc. Let me just take this first array and splice it, so splice obviously mutates the original array. So every time we use something that mutates the array, we have to be very careful with that. But here we are required to mutate this array in place. So I will splice this array, remove all of these elements. So starting from the element with index m, index of this first 0 is m. So starting from this index m, the next n elements will be spliced out and will be replaced with all of these elements from num2. Let's do that. So take nums1, splice, starting from element indexed m, next n elements will be removed, as we said, replaced by all elements from nums2. Right, so after this command, all of these numbers will be copied over here. Good. Now we have to sort the resulting array. So the result is obviously placed inside nums1. So we have to sort nums1 in place again. So this will sort the array in place. A, B, A minus B. This will do the numeric sort in ascending order. However, let me do it the way I normally do it. What I usually do is create a function which I can export. So let's copy this from here to here. But in here, I would need to type them, because now if this is a separate array, types of these are not immediately obvious. Let's also create descending, and we're not going to be using descending, but still, this is normally how I would do it. So once I've created these elements, these functions, once inside my project, this could be exported, and for a larger project, this is the approach I would normally take. Right, I think this is it. Nothing to return here. Let's try testing this on these tests. Oh, we passed all of them. These are very simple tests, but if I submit it, then probably there are some more sophisticated, more complex tests. Oh, we passed everything. Not only did we pass, runtime is pretty good, 0 milliseconds. So these tests are not very sophisticated, not very difficult tests. Memory usage isn't great. So we still beat 91% of other this is very strange. Okay, but definitely, however well we did, this is not an acceptable solution. This is not an acceptable solution, right? One reason why our solution is not acceptable is because we're using sort as a final step here. Sort is much slower than our merge, and this will be the slowest part in our solution. So we have to come up with a way of merging these two arrays together so that the result comes out already pre-sorted without the requirement to sort it after the merge. The key insight would be this. Let's think about any element inside the first array. So where can this element end up after the merge? Well, it can end up in its own place right here, or it could go somewhere to the right. It can never go anywhere to its left. That would be impossible. And that's easy to understand why, because it would stay in place if no elements from the second array end up being inserted to its left before our chosen element. But if any of the elements do get inserted before our chosen element, then it will move exactly that many slots to the right, however many elements end up inserted before it. There is absolutely no way for this element to end up anywhere to the left after the elements are being added, because no element is being subtracted. That's a key insight. This is how this observation will help us. If we start working our way back, so if we start working our way back in the nums1 array, so if we first try to fill in this slot, then we will be comparing these two elements, right? Choosing the biggest one, 12. So 12 will go here. And then, since 12 is now used, we will move to the next element here. Compare these two elements, choose the largest one, 10, etc. So at some point, we will overwrite element 10. Now, this is no longer a problem if we overwrite 10, because 10 cannot ever be needed to its left. If we overwrote 10, that means this value will never ever be required to the left. Now, I think this is an easy insight, so we can now proceed into writing our code. So let's do a small loop. Our main index would be I. So this is our index. This is our index I. And then we will be using two other indices, I2. Oh, sorry. Let's call this I1 in the first variable, in the first array, and I2 in the second array. So I1 would be m plus n minus 1. And then I1 will be m minus 1, and I2 would be n minus 1. We need to go through I, so we need to exhaust every element. We need to populate every element of the merge, and that will be controlled by I. So we're going to exit the loop when I becomes less than 0. Let me reformat everything slightly. That is our step. So that's basically the header of our loop. This is, well, instead of being on a single line, I decided to write it on multiple lines. I think that's easier to read because of this long line here. Right. So now we need to select the target element to put inside the I slot. Now to do that, I'm actually going to create a reference called target to the nums1 array. Now, target is exactly the same array as nums1. It's not a copy, just a reference to the same array, but it's probably better to do it like this rather than keep using nums1 as a target. So target I needs to be populated. That's the whole purpose of this loop. How to decide what to put inside target I? Let's see. So if we have, let's say, exhausted all elements from the first array, that means if I1 has become negative, then we should choose whatever element we're pointing at inside the second array. So if I1 is less than 0, then we have to go to nums2 array and choose element I2 and instantly decrement the pointer. After we obviously select the element, then we have to decrement the index. This is precisely what minus minus will do. If, however, we've exhausted the second array, then we should choose from the first array and instantly decrement the pointer inside the first array. Otherwise, that means we haven't run out of elements in both arrays. Both arrays still have elements, so we can touch both of these elements. They exist, so nums1 I1 is less than nums2 I2. Now we can validly compare these because both of these exist. So if this is the case, that means this one is bigger. So we should select the large one and immediately decrement the index. Otherwise, obviously, we should go for this one and immediately decrement index here. So potentially we could have written this whole thing slightly differently. So we could have done something like if I1 is less than 0, then target I equals nums2 I2 minus minus. Else if I2 is less than 0, then target I is nums1 I1 minus minus. Else if nums1 I1 is less than nums2 I2, then target I equals to nums2 I2 minus minus. Else target I equals nums1 I1 minus minus. So we could have done this, and it would be exactly the same logic. However, I prefer this for the following reason that when you look at this code, even though it kind of looks slightly odd, one thing is immediately obvious, that this whole code is dedicated to assigning something to target I. This is not immediately obvious from here. You have to parse each line and notice that, well, this is repeated on every line here. So you're assigning to the same variable, basically. But that's instantly obvious in this code. So I'm going to delete this and keep the version that I prefer. Okay, that's our whole code. Now let's try to run this. on these three little tests that are compile error. What is expected? Sorry. Line 17. All right, so we need colon. Okay, so we passed all these three very, very simple tests. Let's now submit and run this solution on all of the full set of tests. And we have passed. The solution has been accepted.